Oh dear, sketching exponentials. This does not go well in exams at all. Exponentials and logs. Sad. It's really sad marking these. So let's go through this and let's try once and for all to sort out what an exponential graph looks like, how you can tell what it looks like, and what a natural log graph looks like. Right. These are inverses of each other. So if we know what one looks like, we know what the other one looks like because it's a reflection over y equals x. An exponential graph shows the growth of something coming all the way from minus infinity and getting steeper and steeper and steeper and steeper and steeper and steeper like that. A log graph is the inverse of that graph. So how do we do inverses? We rebrand everything. So we rebrand this asymptote, y is naught, is rebranded as x is naught. We rebrand this point here, which is 0, 1, we rebrand it as 1, 0. The behaviour here, where the graph is going towards the asymptote, will be reflected down here. Remember, asymptotic behaviour is landing aeroplanes, landing, landing, never landed, landing forever and ever. And then it goes up to infinity here, and this one goes up to infinity like this. So this is the graph of y equals ln x, and this is the graph of y equals e to the x. And the most important thing that I should point out at the moment, other than the asymptote, you do definitely need the asymptote equation on both of them. Put it here. The asymptote equation, not just naught, and draw it on. But the other thing is, do not go horizontal. It doesn't flatten out, okay? Do not go vertical. When you're drawing exponential graphs, don't go vertical. It doesn't go vertical. The log graph does not go horizontal. So don't even suggest to me as the examiner, don't suggest to me that you think this flattens out and has another asymptote, because it doesn't. There is only one asymptote here and one asymptote here. Now, we're going to go back in terms of the ideas to transformations of graphs. So for example, y equals, let's say we've got e to the 2x plus 1 minus 2x plus 1, and then let's say it's going to be multiplied by 3 and then have a plus 4 on the end of it, something like that. Okay. How would we work out how to sketch this graph? We would take the journey of the x. What has happened to the x? It gets multiplied by 2. It gets multiplied by minus 1. It has 1 added on. And then e happens. E is our parent graph. E is this one here that we're actually drawing. This is the one that's being transformed. Now what happens? We continue on the journey. He's been doubled, times by minus 2, added 1. E has done its thing. Now times 3. And then finally add 4. Okay, how much of this is happening left and right? All of this stuff here. All of this stuff left and right. It's changing the x coordinate and it's doing the opposite of what it says. Whereas all of this stuff is affecting the graph up and down. It's changing the y coordinate and it's just doing exactly what it says. So let's think about describing the transformation. Everything in here does the opposite. This is a stretch scale factor 1/2 parallel to the x-axis. Stretch scale factor 1/2 parallel to the x-axis, squashes in like this. A reflection, left and right reflection, so a reflection over the y-axis. So it's exponential decay rather than exponential growth. It's going to be exponential decay. And then it says right one, but we go left one. So all of this changes those x coordinates. Then we stretch scale factor 3 parallel to the y-axis. It's going to stretch it away from the x-axis parallel to the y-axis and then up 4. So really quite complicated set of transformations here. Let's see if we can work out what it's going to look like. Right, scale factor 1/2, squashes in, looks exactly the same. Everything's just got closer. Timesing by minus 1 on the inside of the function between here and here is a reflection like that over here. So it's now going to be exponential decay. And then left one, well, that will make very little difference. The whole thing shifts left one, but it's still just going to look like exponential decay. Right, now I stretch it scale factor 3 this way. Again, it's not going to make much difference to the picture, is it? It's still going to look like an exponential decay coming down to y is 0 as an asymptote, and then up 4. Up 4 is going to change all the y coordinates by increasing them by 4, and it's going to therefore increase the asymptote by 4 as well. So I'm going to have an asymptote at y equals 4, and I'm going to have exponential. See, I can't do this without turning myself around because I want to try and be asymptotic to this line. Ooh. There we go. There's my graph. Notice I have not gone vertical, and I now want to find this y-intercept. Y-intercepts are nice and easy, aren't they? You just put in x is 0. So I would get e to the 1, e, 3e, add 4. Ta-da! Easy peasy. Right, let's do the same thing here. Let's make up something that looks disgusting. Y equals 2 minus ln 4x, 4x. There we go. Should we do that one? That'll do, won't it? So what's happened to x on this little journey? Off he goes. He gets times by 4. He gets ln, which is our parent function, which looks like that. He gets times by minus 1. And then he has 2 added on. Right, how much of this affects the x-coordinate? Just this bit. So the only thing that's happening to the x-coordinate is this times 4, but it does the opposite, so we're actually going to divide by 4. Opposite, yes. Change x, opposite, yeah, I think that explains it. And then all this stuff happens up and down. We're going to reflect up and down, so that's a reflection like this over the x-axis, and then up 2. So all these change the y coordinates and they do what they say. So what about our asymptote? Well, our asymptote is on x is 0. This is where all the x changes happen. They're going to get divided by 4 to stretch scale factor a quarter, opposite of what it says. Stretch scale factor a quarter, like this, like that, parallel to the x-axis. So if I stretch everything, scale factor a quarter, then all of the x-coordinates are going to divide by 4, which means this asymptote will divide by 4, which means it'll still be exactly in the same place. Okay, so in terms of the graph, it'll squash in. Won't make much difference, it'll still look like this. Right, now what happens? I'm reflecting up and down like this, so it's now going to come down the asymptote and through like that, and then up 2. So all in all, it will look like this. It'll come down the asymptote. Wow, look, my aeroplane was taking off again. Down the asymptote like this, and then like that. And it is not going, this one is not going vertical, and this one is not going horizontal. So I am not doing, I'll show you what I'm not doing. I'm not going horizontal there, it's continuing down very gently. Now this point here is quite difficult to find. I'm just going to make a note, don't let the aeroplane take, look at this asymptote, right? Aeroplane's coming down, 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 down. See what's happening right at the end there? He's taking off again. Either that or he's landed, I'm not entirely sure. But I don't like this. This is not very good asymptotic behaviour. This to me looks like the aeroplane is either landed or it's got a little bit of curvature at the end there and it looks like it's just going to try and take off again. So this is not the best demonstration of asymptotic behaviour. This is a lot better. This aeroplane's coming down nicely, landing, 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 landing. Right, what was I going to do? Find this. So what's going on here? Y is 0. You take the original equation, you change the y to a 0, and you gently manipulate it. Ln 4x equals 2, 4x is e squared, x is a quarter e squared. Just gently manipulate it into saying x equals so that we know what this point here is.